So in this hour, we'll talk about some additional mechanism of IP address. So as we mentioned before, ICANN divide the entire IP spectrum into several different classes, and each classes we have different subnet can be distributed to different university, different organization, different ISP. But you have to think about one thing: in a single class A, there are 60 million IP addresses in a single class A subnet. So basically, we cannot build a single subnet with such many IP addresses. So after we got one block of IP address, okay, in an organization, we will simply just divided all those IP block into smaller subnets. Okay, let's take a look at this one. Okay, if an IP address has been distributed to your organization, okay, so that is, I think that's 20 bits. Okay, and the rest of the part is 12 bits. So you can see that because we have subnet like this, okay, it is provided by your ISP. But after that, when you get this ISP, how many IP addresses can be used in this subnet? Okay, that should be this one, right? That is almost 4 million. 4 million. Okay, so think about one thing. Could you set up a subnet like this, and you have to connect a lot of different switch, and you have almost 4 million unique hosts in this single subnet? It is impossible. Okay, it is very difficult. It is very difficult to manage such a large subnet. So after we obtain a single block IP block from your ISP, okay, basically you will then do such kind of things. Sorry. Okay, although the original network part, okay, net part is 20 bit, but you can borrow some bit from your host part to a network part. So in this case, right here, we have 23 bits. We use 23 bits to represent our network part. Okay, and again, the first 20 bits are all the same, right? So we have 3 bits can be used to represent different unique network part. We have 3 bit, right? 3 bit. So we have total 8 different network part can be used, right? So in this case, if we do so, we have 8 separate unique subnets. And for each subnet, okay, for each subnet, the host part is 9 bits, right? And 9 bits corresponding to 512 different IPs in each subnet, right? So you can, as a network administrator, you can see when you get a large block of IP address, you can simply just divide it into several different small subnet. Okay, as long as they have, you can specify them with different host part. Right here, okay, we borrow 3 bits from the host ID part, host part, right? So we can create 8 different subnet. each subnet now becomes a /23. Originally, it is /2020, one single /20 subnet, and here now we have 8/22 subnet. So in this case, right here, so in this case, we can buy a lot of routers, 8 routers, and each routers, as we mentioned before, because it is a subnet, we have an 8 new subnet, right? So each subnet should have a 8 router right here. So you need to buy 8 routers and connect it to another router. So in this case, we can divide a very large network, subnetwork, into 8 different smaller subnetwork. And since they can be uniquely identified, right? So you can simply, I think that is a wrong number. That should be 17. Okay, so you can put this specific subnet in some other place. Okay, for example, 16 represent the organization 1, 17 represent organization 0, organization 1, and you can simply just put the subnet in under other ISP or under other geographic location. It is okay because you don't those IP addresses they are not necessary to be located at the same location. They can in our campus network we simply just do the same thing, because for NCCU, okay, we have a class B network, which is we have a class B network, but in class B network there should be 65,000 IP address in a single subnet, but we don't do so. We simply just divided this class B, right, this class B network into 256 class C subnet, and the first one should be this one, the second one should be this one, until usually we will not use class B or a class A in our organization, because that is too large, right? So usually we can divide the class B network into 256 class C subnet, and we can buy a lot of different routers to as the edge router of this 256 subnet. So that is more convenient for you to distribute, to organize your network. Okay, as a network administrator. Okay, we can skip this one. We'll talk about other things. Okay, the next topic we are talking about is NAT, network address translation. I think you have heard of one thing. You have already know one thing, is that IPv4 IP address is not is already used by all the organizations. We don't have any new IPv4 address can be used, right? So the root cause is that 32-bit is too small. So we have only 4 billion IP address in IPv4, but we have even more IP addresses in need to be used devices. We have even more devices, okay, on the earth. So we should use IPv6 right now, because IPv6 has 128 bits to represent an IP address. So it is much larger than IPv4. But currently, we think about one specific mechanism called NAT, okay, to use a few IP address in the subnet. Okay, take a look at this one. Right here, you can see that as we mentioned before, okay, this IP address should be bind on the network interface card, right? So at the right hand side, we can see that this is a subnet and it has 4 network interface card. So usually, okay, ideally you should use 4 different IP addresses. But as we know, we don't have that many IP addresses can be used. For example, you have very limited public IP address. So in this case, in this LAN, local area network, okay, we can use the IP addresses in the orange part, which means we can use the private IP addresses preserved in this IP spectrum in our local area network. Okay, so take a look at this one. Okay, it used 10.0.0.0/24 as its IP address, and as we know, the IP address starts with 10. It's a private IP address, right? So ideally that there should be a DHCP server, and here we have IP address right here, and everyone who arrives this subnet, the IP address, the DHCP server will give the newcomer a private IP address starting with 10, which is a private IP address. Okay, so as we mentioned before, if any one of, for example, this A host would like to open a socket with host B, as we mentioned before, because it is a LAN, every packet, every datagram sent from this network interface card will be received by every network interface card in this subnet. So when A would like to communicate with B, actually every network interface card right here can receive this specific diagram. Okay, and then after B, for example, B replying to A, and again, everyone in this subnet can hear, can accept, can receive this IP packet. But the operating system will filter out the IP diagram that is not belong to this network interface card. Okay, so if A want to send the packet to B, actually C and the router and the DHCP server will receive the packet, but only B will unpack the packet and send it to the layer 4 and layer 7. Okay, and C, DHCP server and router will drop the packet. Okay, if the destination IP address is 10.0.0.2. Okay, so in this case, we can use private IP address in the LAN, right? In the LAN, but there's a rule that for all the routers, okay, for all the routers in the internet, if all those routers they receive a packet which its source or its destination IP address is a private IP address, and this router will simply just discard or drop this packet. Okay, so an IP datagram with private IP address cannot be forwarded or be routed in the internet. You can only use private IP address in your local area network. That is the rule. Okay, so routers will not route a packet with the private IP address. Okay, so how But what if this host A want to communicate with some server in the internet? Okay, so let's just skip this one. We will explain this one. Okay, so again, take a look at this one. We have ABC right here, right? And we have some interface card right here. And again, maybe we have a DHCP server. Right here, maybe they all connected to switch. Okay, so at the right hand side, it is a LAN. Right, at the right hand side is a LAN, and all of the network interface card, they use private IP address. And right here, that is a router, right? As we mentioned before, those packets with private IP address cannot be routed in the internet. Okay, so in this case, this router has another role, which is NAT server. Okay, so that is network address translation server. So let's take a look at this packet. Okay, this red packet number 1. Okay, this packet is from A. So this packet's source IP address is 10.0.0.1, and the source port is 3345. Okay, that is a random port number selected by A. Okay, and it would like to talk to a HTTP server right here on the internet. Okay, the HTTP server of course has a network interface card, and there is an IP address which is 128.119.40.186. Okay, and you can check it out with the IP spectrum we introduced last hour. Okay, 128.119, it is a public IP address. Okay, so in this case, a host A in a private LAN has a private IP address. Would like to talk to a IP, destination IP, which is a public IP address. So the packet, the datagram, the source is 10.0.1, port number, source port number 3345, destination IP address 128.119.40.186, and destination port is 80. So as we mentioned before, every packet transmitted in the LAN can be received by B, C, and DHCP server, and again the router, which now it is act as a NAT server. So when the NAT server receives such datagram, and it take a look at the source IP address and the destination IP address, and it says, okay, a private IP address would like to talk to a public IP address. So as a NAT server, it will create packet number 2 by using its public IP address, which is 138.76.29.7. It is a public IP address. So at the left hand side right here, it is public internet. So this router has 2 interfaces. One is private IP address. It can talk to anyone in the private LAN. The router, as an NAT server, it has another interface which has a public IP address. It can talk to any host in the public internet. Okay, so in this case, as an NAT server, the server will remove the IP header, okay, of packet 1 and attach a new IP header, which its source IP is 138.76.29.7. It's right here. because that is the only public IP address the NAT server has. Okay, so it will replace the private IP address by using its public IP address, and the destination IP address is still the same. Okay, because it will go to the HTTP server. Okay, but you have to think about one thing right here. When the NAT server do such kind of address translation, okay, it use a new source port which is 5001. Okay, so the NAT server has a NAT translation table. After it received the first read packet, okay, it had to specify an entry in the NAT table. Okay, says like, okay, I use a new source port 5001, okay, and replace it with the old IP private IP address and its corresponding source port 3345. So this second packet will be routed and forwarded in the public internet. Okay, and the packet, when the packet arrived to the server will think that, okay, there's an IP address which is public IP address 138.76.297. Source port is 5001. Would like to communicate with me, which is a HTTP server. So the packet, the HTTP reply comes back. So the source IP address is still 128.119.40.186. Source port is 80. Destination IP address should be 138.76.297. 5001, because this packet can be routed and forwarded in the internet. So after the NAT server get this specific packet, it will take a look. We will look up the NAT table. Okay, it says, okay, the destination port is 5001. So again, the NAT server will remove the original IP header in packet 3 and attach a new IP header by using the corresponding private IP address and its corresponding port 3345. So that is here, right here. This packet can be transmitted in the LAN, right? So host A can get such kind of such packet. So in this case, no matter you are A, you are B, or you are C, you use different private IP addresses. Okay, you can use the IP address, the public IP address of the NAT server, and the NAT server can help you to do such kind of translation, so your packet can pass through the NAT server to the public internet, and can be routed, can be handled by the server, can be replied. And after those replies goes back to the NAT server, the NAT server will again change the IP header by checking the NAT table. And again, those packets can be received by the A or B or C by using the private IP addresses. So that is the idea of NAT. Okay, we have a NAT server. It can help us to translate public IP address and private IP address and corresponding ports. That's it. That is the idea of NAT. So in this case, no matter how many different hosts that you have in your private network, okay, you can use several. You can use different. As I mentioned before, you can use different private IP address in your private network. Okay, use 10, class A, class B, or class C, no matter what kind of class you use. Okay, they can use a single public IP to communicate with the entire internet. Okay. But before we finish this topic, there are some additional things we'd like to talk about right here. The first thing is that when the private IP address, okay, would like to pass from the right-hand side to the left-hand side, the entity server will create the corresponding entry in the entity translation table, right? So that is the moment that this entry has been created. So if the entry exists, packet number 3, packet number 4 can be handled by the entity server correctly. So, but when you finish your communication, for example, you terminate your TCP socket, for example, and the entity server will remove this entry in the entity translation table. Okay? So the port number will be released for the later use. For example, B can use can establish another communication to the public server. Okay, and the entity server can reuse the 5001 port number in other entry, for example. Okay, but there's a very important thing is that the entry is created when the first packet goes out. Think about one thing. If you have a HTTP server in your private network, okay, it is impossible for the people who in the public internet to access this private HTTP server, because for example, you would like to do such kind of communication, the purple one. Okay, it is not possible for the NAT server to do such kind of a translation because there's no entry that for the HTTP client, the purple HTTP client, to pass through the NAT server and reach the HTTP server in the private network. The reason is that the first packet sent from the HTTP client in the public network, okay, the source IP address is very simple. It is the HTTP client's IP address. But what is the destination IP address should be used right here. It is the public IP address of the router. No, it should not be, because when the packet arrives the NAT server, right, it does not open any socket at port 80, right? So because it is not the HTTP server, the router is not the HTTP server, so the packet will be dropped it. Okay, so what if the HTTP client used 10.0.0.2 as the destination IP address to send this purple packet? It is not possible because we mentioned before, in public public internet, you cannot use private IP address. The IP address will be discarded, will be dropped by the internal by the routers. So you cannot do so. So it is impossible for you to set up such kind of FTP server in the private network, trying to serve the client in the public internet. So here we would like to introduce another table called port forwarding table. Again, port forwarding table is very similar to NAT translation table, but as I mentioned before, NAT table is the entry is created when the first packet goes out from the private network to the public network. So it is dynamically created and dynamically removed from this table. Okay, but the port forwarding table is a manually created table. So you can simply write when 80 goes to LAN, for example 10.0.0.2 port 80. That means you can manually create a port forwarding table on the NAT server. And the NAT server will help you to pass the purple packet right here. So that is you can see that the port number right here is 80. That means when the server, NAT server, receive a packet from the internet, and the destination IP address is its public IP address, but the port number is specified right here, that means this packet should be translated to 10.0.0.2 at destination port number 80. So this purple line can be realized by such kind of port forwarding table. You have to manually create an entry in your port forwarding table to make this HTTP server can be reached by the public host. Okay, you have to manually specify this kind of a port forwarding entry. Okay, that is okay. So it also the NAT server also indicate that if a packet, okay, it is not in a NAT table and it is not in port forwarding table, it is never, this packet cannot reach to any host in your private LAN. So NAT has some level of provide some level of security mechanism, because no one in the public internet can access your private machine unless the packet is in either network translation table or it matches to an entry in port forwarding table. Okay, so NAT provides certain level of security. Okay, and the next question that I would like to talk about is this figure. Okay, this figure. Okay, think about one thing. Okay, at the top right hand side, okay, we have a host A right here, and it is in a NAT. So we have a private LAN at the right hand side, and it has a router right here. Okay, and of course the router has a public IP 1.2.3.4. Okay, at the bottom side there's another host B, and it also in a private LAN. So its IP address is 10.10.10.8, and its corresponding router has a public IP address which is 5.6.7.8. Okay, so we have two hosts, A and B. They both in their own private IP, private LAN, and their private LAN has a router serve as a NAT server, and they both has private IP, public IP address. And think about there's another host which is S, and it is a public server, so it has a public IP address. Okay, think about one scenario. Okay, if A and B are, for example, playing a game. Okay, and they would like to communicate with each other, which means A would like to, for example, send voice over IP to B. Is that possible that A and B can communicate correctly with each other? The answer is no. Because if A would like to talk to B, A need to know B's public IP address, which means it is R. It's 5.6.7.8. But there should be one entry, port forwarding entry or a NAT entry that can let A to go the red line. A goes the red line to pass through the NAT server, the green NAT server, and then go to the public IP address, public internet, and go to the red NAT server, the blue NAT server, and goes into B's private network. It is a very complex situation. So usually, without any information, A cannot directly talks to B, and B cannot do so. So, but right now, NAT is a very popular mechanism, very useful mechanism in your home network. So basically, every home network, no matter you use ADSL or you use cable network, basically you have a private network in your home network, basically. Okay, so it is impossible for user A and to talk to user B directly when they both hidden after their own NAT server. So in this case, a lot of game server or game mechanism, they have to set up a server at the public domain, at the public internet. So A need to talk to S using the green communication. It is okay because A can talk to S using the green communication. So S, the server, knows what is the public IP address used by A and what is the port number used by used in the translation used publicly. Okay, and B can talk to S as well by using the blue line. So S knows what is the public IP address used by B, and S can exchange messages for A and B. So A and B knows what is the public IP address, what is the public port used. Okay, and A can report what is the private port it used, what is the private IP address it used, and B can report what is the private port and what is the private IP address be used. So S can get all those information and share it with A and B. So after that, A and B can talk with each other when the port forwarding, when the NAT table entry, the mapping has been exposed by A and B and shared by S. Okay, but there's another question: is how S knows what is the public, how A knows what is the public IP address used by its NAT server, which is 1.2.3.4 right here, and what is the public IP address 5.6.7.8 used by the B's public, used by B's NAT server. And I would like to introduce something like this. Okay, basically you can simply just go to what is my IP. You can simply just Google what is my IP, and you can see that there are several different web pages that can help you to do so. So we simply just click one of them, and it says the public IP address used by my current my iPad is 123.195.116.124. Apparently it is a public IP address, but let me show you what is my private IP address. Currently my private IP address is right here. It is, do you see that? That is 192.168.0.15. That is the cable, the IP address used in my home network. So I have an NAT server in my home network, but the actual IP address is 123.195. blah blah blah. Currently, that is the public IPv6 address that used right now. Right, by my used by my cable modem. Okay, but how this server, know my public IP address? This is very simple, because you can simply just send a packet from A to S. Okay, and in S, okay, when it receives such kind of packet, it knows it from 1.2.3.4, so it can write such kind of information in their 7 content. For example, in the HTML page. When this HTTP packet, okay, which contained 1.2.3.4 information in the layer 7 HTTP HTML page, when it goes back to the router, to the NT server, okay, although this IP datagram, its header, will be removed by the NT server and will be attached, will be removed and will be extract, will use the private IP address, which is 192.168.50.3, will be replaced by this IP address. But it only replaced the layer 3 header, but the layer 7 content, which include the public IP address, which is 1.2.3.4, will not be changed, will not be removed by the NT server, because NT server only remove the IP diagram header, not the layer 7 content. So when A, which is me, receives such kind of HTTP packet, when I display the layer 7 content in my browser, it will specify, okay, your public IP address is 1.2.3.4. So it's very simple and very trivial things to do so. Okay? I would like to talk about something about the right-hand side, left-hand side. That is another example. We use an AT. Okay, we should stop right here. Okay, the left-hand side. I think you have maybe you have used this function in your mobile smartphone. Okay, that is called hotspot. Okay, so right here we have an M. M is your mobile phone. Usually your mobile phone has several different network interface card. For the left hand side is your 4G or 5G network interface card, and you will obtain certain public IP address from your 4G network or 5G network, and it will help you to connect it to the public internet. Okay, and at right hand side, if you open if you turn on your hotspot, okay, your mobile phone will become a NAT server and a DHCP server. So at the right hand side, we have a Wi-Fi antenna, right? And this Wi-Fi antenna will create a subnet. For example, usually it will use a 192.168 dot blah 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 to create a subnet, and it is a private network. And you can use your another device, for example, your PC, your laptop, your iPad, and you simply just connect it to your hotspot, and your hotspot, right, your mobile phone will provide a private IP address by using DHCP. Take this for example. It helps the iPad to get a private IP address 192.168.114 and 142. That is a private IP address. So your iPad can get this private IP address. And when the iPad wants to talk to some public server in the internet, it will use the private IP address and pass through your mobile phone, and your mobile phone will serve as a NT server and use the public IP address. For example, right here 114 dot blah 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 blah, and goes to the internet. The packet will goes to the internet. So your hotspot is it's very convenient for you. It's very convenient for you to share your network to some of your device. But actually, it is a combination of NAT and DHCP server, and they use a private network in your Wi-Fi network, and in your 4G or 5G network, you can get a public IP address from your 5G or 4G service provider. So that is how NAT and DHCP works when you turn on your hotspot. So I think that is the thing you need to know about hotspot. Okay, let's stop right here, and we'll talk about some other things next hour.